Okay, so again, come back to CSC 201 class. We gotta cover chapter 11 about inheritance and polymorphism. Now, let's look at the topic. So we gotta talk about concept of superclasses and subclasses, like the parent class and the children class. And then we have to involve like how to use super keyword to refer to the parent or the superclass. And then in that case, we have to talk about overriding. The method can be override. The children class can override the parents class methods. And when we talk about overriding, we have to cover overloading. So what's the difference between overriding and overloading? So overloading, pretty much overloading going to look at the methods in the same class that has the same name but different signatures. Signatures mean parameters. So that's called overloading. And overriding means the method of the class that has the same name, same signature, but is in the children that overriding the parent. Okay, because parent has the same method with the same name, same signature. We're gonna look at an example. And then we're gonna look at object class. So like object class, pretty much all Java programs, they are inherited from object class since your first Hello World program. And object class has one method named toString. So we're gonna talk about a toString method of the object class that normally when you do last time we talked about object-oriented thinking, and when we create class we should create toString, and toString pretty much overriding toString of the object class. And then we have the concept we call polymorphism. So poly means many, morphism is form in Greek, so it means object can have many forms. And then we talk about the dynamic binding. Okay, so when you have several when we have the children class and parent class, and we have constructors, and when we call constructors, it's going to be involving with the dynamic binding that we're going to cover. Like, let's look at an image. Like, so this is an image. Okay, so let's talk about the dynamic binding again. Like, for example, a method can be implemented in several classes along the inheritance chain. And the JVM is the one who decides which method to be invoked at runtime. Like for example, we talk about object and toString, right? Like toString is a method that defined in an object class. Now, when we say geometric object is a class that overrides toString method. When we do o.toString, the question is it going to call toString of the geometric object, or it's going to call toString of the object class? So that's pretty much the distinct. So this is called a dynamic binding. Okay, so we're going to get into details, but I just want to show you an example of this topic. And then let's go back to the list of topic in the beginning. Okay. Sure. And then we talk about casting objects and instead of the operator. Like, since we going to involve with the object, right? Now, casting is the techniques that we know. Casting, when you want to change the data type, right? You use cast, right? And casting object. So let's think about, we know that all the classes, they are inherited from object class. Now, when you get the instance as an object, can we change the type to any other type of like instant classes? Yes, we can do that. We can use the casting technique, just like the same casting technique we use in the primitive data type. And we're gonna look at that. And then that's the reason why we have the instance of operator, which it can check that is this object is an instance of like student class, car class, or any object class, geometric object class. So to check that object, we will talk about that in details. And then we have the equals method. So the equals method is a method that compare the reference to the object. Just like we already used this when we talk about string class. You cannot use two equal style to compare, right? You have to use the method dot equals because this is an object. So this is the equals method. Now we want to talk about how we're going to implement that, right? For different objects. And then we have a class named Arraylist. We pretty much learned array already. Now we're going to talk about Arraylist. It's pretty much just a version of an array in a class format. And then we talk about lists, and we're going to talk about the methods of the list class. So this is starting to talk about something that you should focus to induce to the next level, which is CSC 202. So this topic is very important to understand. Yes. And custom stack class too. This is pretty much an application of the list. And yeah, 202 is going to talk about stack. And this structure stack is here. And then we're going to talk about, we know public and private already. So public is we let the access to the world. Private is only valid in the class. Now, since we have the inheritance concept, like parent and child class, then we talk about protected data type. Right, so we're going to see public, private, and now protected. And this one you should focus on because we have that on the test. And the test is coming in 2 weeks too in that topic, chapter 11. So you can have the same like public, like the data, and public methods, same protected data and protected methods. And lastly, all the classes can be inherited. When you inherit, we talk about extend keyword. And the method can be overridden. So how are we going to preventing the class to be extended and overriding methods? So we're going to talk about that. Alright, so that's pretty much all the topic we're going to cover. So let's go to inheritance and polymorphisms. What is inheritance? Allows you to define new classes from existing classes. So that's inheritance. So it's an important and powerful feature for reusing software. That's why we want to do inheritance. So for example, if you want to define a circle, rectangle, and triangle classes, you may see that these classes have something in common, many of them, right? Like, for example, the common thing could be get area, get perimeter, right? Those shapes has area and perimeter. So how are we going to reduce or avoid redundancy and make the system easy to comprehend and easy to maintain? Like, you don't want to write the same thing over and over again. So we say we can use inheritance to help. So inheritance enables you to define a general class. So we want to define a general class. Pretty much everything that is in common should be in this class. For those 3 classes that we see, circles, rectangles, triangles. Like, if we identify that get area, get perimeter are in common, then we define general class. And then the specific class like circle, rectangles, triangles can be subclasses. And we extend from the general class. In this case, we're going to create a general class named geometric object. So this general class is going to have something in common for those 3 shapes, right? Which is color, filled, date created. So those 3 are in common, right? Like we see, circle should have color, triangle should have color, rectangles also should have color. So that's why we define color. And date created is also common. Get color, get filled, get date created are also in common. Now, this is a symbol to represent inheritance. So we see circle extends. This is a keyword for inheritance in Java. The geometric object as well as rectangle. The things those are not common that belongs to its own class is circle has the radius, rectangle has width and height. So we define it under its own class. And then the rest, like get radius, set radius, get area, get perimeter. So it looks like get area and get perimeter should not be in common because the way they calculate it, right? Like circle to find area is not the same as rectangle to find area. So that's why I just divide them in own class. When we do extends like this, meaning that the attributes or the data like color, field, date created will belongs to circle and rectangle class. All right, so we look at how we create the geometric object, right? So geometric object, this is the general classes. We define color, field, date created, create a constructor for that. Two constructors. So these two constructor has the same name, and this is called an overloading concept, right? With different signatures, right? This one has no signatures or no parameters. This one has two parameters. So this is called overloading constructors. And then inside pretty much just define, initialize the data field. And these are just common getter and setters. And when you do inheritance, we just use the word extends, like circle, form, simple geometric object, right? Extend simple geometric object, and define on radius, on constructors. And this is pretty much has three overloaded constructors. The date methods, let's come back right here. We could just say new date if we import java.util in the beginning. This one just happened to import right here, right? All right, so the thing is sometimes date belong, like class can be common. We may create our own class name date too. So that's why you want to specify the package location of which date you refer to. So that's why it just say java.util and it's just omitting the import statement. So that's why I just declare like that. Okay, it's the same thing. Just providing path to the class. We call package. So the rest pretty much the same, like getters, setters, and calculate area. You know how to do that, right? It's square, right? Radius times pi. Okay, so the key is we want to focus on circle now is a superclass. No, I'm sorry, circle now is a subclass, and the superclass is the geometric object, which is a common class, right? So that's how we inherit. Just use the keyword extends. All right, so rectangle is the same. Just use the extends keyword. And this is a class for rectangle with width and height, with all the constructors and getter and setters for width and height. And to calculate the area, just width times height. To calculate for the parameters, just 2 times width plus height. And this is just the main now, or the tester, that I pretty much asked you to run on unit test, right? Create the object and then test to print out. Any questions so far on circle and rectangle inheritance from geometric class? Now, let's talk about super keyword. So super is a keyword that refers to a superclass when you say super. And you can use that to invoke the superclass method and constructors, because now you have subclass and superclass, right? We only learned that this reference, right? So when we say this refers to its own class, right? But we use super. Super refers to the parent instead, right? I use the same thing just like this, but refer to different classes. And this is a super constructor, refer to the default constructor of the parent class. And this is super with the parameters. It's very common that in the constructor for circle, it's going to call a super to create a geometric object first by passing color and field, and then set it on radius. So that's how we use the super. Questions? Do we need to show you? Yeah? Okay. So let's talk about so let's create a new class. And this is the geometric, right? This is the common class. And we will talk about this common class has private string color, private date created. So now the question was asking also, I could import java.util, right? Instead. Then I don't need to do java.util. If I don't do that, I could just type java.util too, without import. So it's technically the same thing. Sometimes we like to do this when we have more than one date class to invoke. Like we could invoke another date from another package. Then how we going to import two of them? It's kind of confusing. Then we have to type it out. Like you say date again. You see we have another package, java.sql date, or this date, they all date. See, if I want to use this, then I'm going to import, or otherwise confusing which date you're talking about. Extend is inheritance. Import is get the object to use in your class. It's not. How is different between you are inherited from your dad and you live with your dad in the same house and then your friends come over and stay over at your house. Because there are no inheritance relationship, but sometimes they can just get into to use into the same class through the import statement. Like your friend may stay over at your house, but he still cannot drive your dad's car. But you still have an access to your dad's car to drive, but not your friend. All right, so now let's apply that concept here, right? So import, we only import a date to use, but date is not geometric. It's two different objects. Do you agree? So that's pretty much answer to your question. What's the difference between import? Import only invoke date because we want to store the date when we create an object. Color also invokes string class, but geometric is not a string. Why do we need to invoke string? Because geometric has a string. Has it. Like remember, object created from another object. Like geometric created from string and date. Public geometric. This is a constructor, default constructor. We said geometric when we created this geometric shape should have color, right? Color equals to, by default, I may say, okay, white, if it's never specified it. And created date is going to be equals to new date, like the current time. So that's become a geometric object. But we have to import date and string. String technically is automatically imported from java.lang. String is also imported. We create a new object from date and string object. So it's just like a car. This is a tire, and this is like a wheel. Okay. We could create another constructor, and this is called overloaded constructor. Overloaded constructor take the parameters to initialize the color of your geometric object and also the date that we created it. Like now we said geometric object pretty much has two attributes. We could add more. So it's pretty much what makes geometric object. That should be the attributes of it. Can you tell me what makes geometric object? What makes geometric object? Hmm? Say it louder. An area?
Depends on the object, because like a circle, you can't say length.
So this one said making geometric unit date, color, and if the shape is filled or not filled. So that's what makes geometric object. That's what it say in the textbook. Is it filled object or not filled? Is it what color of the object? The area is actually, yes, it is part of geometric object. But is it common? That's another question. Common means what?
All objects share the same attribute.
Yeah, objects share the same attributes. So this should be Boolean, right? Field, not field. Is it sharing the same area for the geometric object like circle, rectangle, triangle? Are they sharing the same area? They have the area, but the way they're calculating area are different. So that's why we didn't put it in here. We only put the one that's common because we try to create a common class first. So what else make geometric object between, like, you just give us area, what else? Hmm? So we finished two constructors. What else do we need to create it for the class? What else do we need to create it for the class? I want you to think about that. We talked about it, right? From thinking as object, right? Set and getters, right? How do you create set and getters? Okay, that's one way, or you type out, right? And what else do we need to create besides get and get setters? What else? Where you create objects, thinking in terms of objects. You create geometric object, right? What else? Constructors, setter getters, and I mean these are methods. These are all methods. But what is the method name that we need to create? ToString. Is override to object. Object has ToString. Like technically this geometric class actually extends from object class. But this is hidden. Just like technically this one have to import what java.lang.string, but you don't need to do that because it's automatically imported for you. All the classes under .lang, java.lang. Same, this is just automatically extends for you. This is hidden. So that's why normally you do string class, right? String return, right? String to string, right? So you see that? Is that right? So what's toString supposed to do? What's string supposed to implement? Output the value of all the attributes of that class, right? Or the object, right? Like color, created field, right? So technically what? The format is just like to do like this. like the list of the attributes, like color, and the value of the color, see this dot color, and then concatenating back, close the color, and then what else? Maybe if you want to do the attributes, next one is what? Field, and then created, so date, so it's created date, color, created date, and then this dot created, and then what else? Field, and then the value of it, this dot, field. Is that correct? It looks like it is, right? No errors, no complaint, right? But it's not. Do we have to put? It looks like I don't have to put. It didn't complain. Like if I use this, but you get to the point. Get to the point that why I need to put. Let's try to see if I put the annotation override. Now I have an error. Method does not override method from its superclass. What does that mean? Maybe I don't know what it means, then I say, okay, don't override it. Is that a good way to do? There you go. The reason why we want to put override, because my intention is I want to override the toString of the object. If I forgot to put override, there's no errors. And I can still use .toString, just like another method name, but it's not really overriding it. So that's why it's not required you to put override, but it's actually help you to check your intention to override, because you could mistype, right? And then you may thought, okay, it's good, but you never override. So that's the point of the override annotation. That's it. It just help you to double check. It's just help to check for you again. Now we already know what's override, right? And we're gonna talk about it in details in override too.
So why do we need to override the toString? Can't we just can't that object just call the toString method?
Because there's a benefit of that. Like, remember when you want to do system.out.print, you can put the instance name right away. You don't have to do .toString. Maybe I have to show, right? Do I need to show that? All right, so let's test this geometric class first. So that's how we test our program so far, correct? This way just return string, right? Because it's test, normally we don't do it. So let's just pick one then. We want to create an object from geometric. So we're gonna call it public. Now let's make an object as private. Geometric equals to new geometric. How would I print out the toString of geometric? How would I print it out? I want to see the values of each attributes of my geometric. How do I do that? Is that the only way to do? Is that the only way you know how to do? That's another way. You don't have to do .toString. If you override it, you see that you get the benefit of that. But if you don't override it, then you just put instance name. It should return all the values of that. And that's the benefit of, that's why you want to override. See, that's why you want to override toString of the object. If you don't, again, it depends on your question. Is your question said don't override like this? Is that your question?
No, my question is, why do we have to create a method in the first place rather than just call it from the string class?
Why we have to create a method named toString?
Yeah.
If you don't create toString, you have to, how you going to get all the values?
I thought you could just like, instead of, I thought the string class is by default imported into every program you create. So like if you create an object geometric, you just call geometric.toString. The toString will be from the string.
Okay, try then. If you should try everything that you suspect. If you don't create toString, you want to call .toString, how could you get the values out? It's going to return, okay, what is it going to return? Tell me. It's going to return this. And you know what's that? It return, yeah, the hex value. Pretty much just an address of that location of that object. Okay, now come back to your question. What's your question again? Why we have to create toString? Is that your question?
Yeah, I was thinking rather than create overriding to string, since the string class is already implicitly imported into this program, use an object to call the toString method in the string class somewhere in the package.
Yeah, toString only have this for you, but then give you the values. And reason that they have this for you because I just show, then you don't have to invoke .toString. That's why. But how could toString understand right away that you have fielded, you have color, you have date? No, there's no way. There's no autopilot like that. It's not. I'm thinking someone will drive the Mercedes for me in front of my house. There's no like that, right? I have to work for it. Same thing. But a lot of students always thought like that. I want to make it easy way, get it, and then no, there's no like that. You have to make it. And then after you make it, then somebody else use it, then they thought the same way now. And then they thought it's even better and better. There's no such that yet, unless everybody build it first. It's possible to have it that way if you rewrite as Java code to be more. But how could we do that? Because there's no way to know that what am I going to type next. That's no way. Then that's why we cannot make it yet. Make sense? Okay. So I guess that's answer your question because you have to create it. Now, is that it for the or the method that we should create for the class? Need to override, right? You don't have to overwrite, I told you, right? It still work. But that keyword just helping us to make sure that you type it correct, like you meet your intention to overwrite. So now we have a superclass named geometric. We like to create a subclass, right? How do we make a subclass of geometric? So name circle. You have to use the keyword extends. Form geometric. Okay, what's wrong here? Because circle happen to be inside this package and geometrics happen to be no package for that. Right? You can move circle out to be in the same location. All right. Or if it has a package for geometric, then you can import it. Like now I didn't create a package for geometric. So now I just extend geometric. So circle is a geometric now. Meaning that if I want to test, I could create object circle. Now what happens if I print circle? Your test can be just like that, huh? So what you expect to see as the output, that could be your test too, right? This is your circle. You extend geometric. What do you expect to see from when I print circle? Why?
Because it's looking up the chain, it's not finding the overwritten two-string in the circle class, so it's looking at its parent class for the two-string method.
So this is called dynamic binding, like chain of constructor. Like this circle, when you don't define constructor, it's implicitly define the default constructor for you, which is that. Okay. And the default constructor, when you not implement anything, is implicitly called super constructor for you, like that. So that's why when it invokes super constructor, it invokes the geometric. That's why you have white. They created the same. It's true. It's just like it's always hidden, just like I told you, it's extends is hidden, right? Import java.lang is hidden. Same, when you don't do anything, it's just hidden and do it for you. But this is what it did for you. And this is the keyword super. Okay. Now you may see that since you are geometric, circle is geometric, then circle technically can access everything belongs to the parents. Just like you can drive your dad's car. You can sleep on your dad's bed. You can wear your dad's shoes. You have everything that your dad have. Circle has everything. Look, get color is fill everything. Like two-string, it has two, right? It has everything that the parent has. So that's the benefit of inheritance. What was the point of using inheritance again? Hmm? Why we want to use inheritance? Hmm? Right, right. Because color going to have that property of the geometrics. Why I have to rewrite this whole thing again? If you don't do inheritance, meaning I have to do the same private field, private date, right? Private color. Is that better? Now, that's why I think in common is going to stay in the parent class. Like radius itself should not belong to all the geometric shapes, right? Does rectangle has radius? No, that's why we should create your own now, right? Your own data field, which is you can make it as double, right? Radius. Make sense? And the same, we could start to do overloaded constructor. Now when you do this, overloaded mean the signature, right? That's different. So we gotta do, we pass in the radius. Same thing here. You could, this is like hidden. right? And you could do public circle. We talk about super. That's how you use super, right? With also take it, but color, because we have color too, right? Circle is the geometric. Date. What else? Fill it, right? And radius. And this is our this circle called what do you call that? Overloaded, correct? Now, what's the best way to initialize your circle? Can anyone tell me? With all those attributes.
Invoke the super constructor with those attributes.
And pass that in. Because we already have constructor created, right? With 3 parameters in the parent. See, it's reduce redundancy, right? Make it more convenient. So what else do we need to do? So these are the basic methods and constructor that you need to create when we create the objects. What else do you need to do? Get us this, right? What else? And toString. Like, that's why these are common. That's why IntelliJ create a way for you to auto-generate it, because those are a common thing. So we're still missing something on toString. This is only show radius. We want to show the color too. Then we invoke the toString of the super. How do we do that? Right. That will not work because it's not an instant name. Super, just like this to refer to, this refer to circle, right? Super refers to geometric. And that's pretty much it for circle. So we do the same thing with rectangle. Now, let's see, we were talking about this guy, right? That's what I want to show you, right? And now I show you super or super, right, with parameters. That's how you know. Like that. All right, now come to constructor chaining. Yeah, this is the chaining that we just mentioned. I just show you. Like this is equivalent to that. It's just hidden. Correct? I just show you as well as this guy. Same thing. This is called constructor chaining. That's what we talked about. This is just an example which we already mentioned. Same thing. And this is how we call the method, like I just show you with dot to string, right? Or you can just call another method too. Now, let's talk about overriding. What's overriding? Like, for example, we see that the method in the superclass is not really give what we want. Exactly just like your toString. That's why we override. Like, if I still keep the same toString, it's not going to include radius, right? Then we override toString. It's the same name, same return, same signature. We call override. And we just modify it to be our version of toString to include the radius. That makes sense? And I mean, it's not just this. You could just have override in different method, not just a toString. Now, when we talk about overriding, then we're going to mention what about overloading? You already see overloading in the constructor. Like, these are the overloading, same name, right? Different no parameters with one parameters with different parameters. This is called overloading for the constructor. The method itself could do overloading too. Let's say you could override set radius if someone call set radius without providing the parameters. This is called overloading, right? And then you could just say, in this case, we give the default radius, something like that, right? That's the overloaded. This is another example of overloading. So we have a class A extends B, B is the parent, and B has the method P. So on the left hand, this is overriding, right? Override because same signature, same method, same returns, but implement differently. And how about this? B has P, and this is called overloading because different signatures, same method name, but this is taking in an integer instead of double. Okay? Any question on overloading and overriding? Alrighty. So we talked about toString already. Object actually has a toString. Like I told you, it's implicitly extends object, right? We talk about that. Now let's talk about polymorphism. All right, so let's stay focused a little bit. You guys see this on the test too, right? I mean, I used to be a little bit confusing, but when I went to a job interview, they asked me this question too: what's polymorphism? Yeah, for the junior, very long time ago when I went to. Yeah, but I get the offer too. So, but I still at that time I was a little bit confusing because it's just a it's just fancy word, huh? Polymorphism. It could make you confusing because just a fancy word, but it's just nothing. Like the question is how many ways that you can do polymorphism in Java and how you do it. So first, what's polymorphisms? Now you know that the object, when we create an object, right? This is how you create object, right? Polymorphism, that means object can have many forms. Form, that means like types. So what's the type of this object geometric? What's the type? Geometric. So only one form, only one type. What's the type of circle? Circle. Only one form, only one type. Now if I want to create polymorphism, I could say have you ever seen this? Hmm? No, we didn't talk about generics yet. This is called polymorphism. That's it. Why? Because the shape is a circle and the shape is also a geometric. Shape has two forms, right? That's it. That is polymorphism. And the question, right, said how many ways you can create? One way through the inheritance. Because circle extends geometric, right? And how you do it? That's it. That's how you do it. Geometric shape because new circle. Now, why we want to do it and what's the benefit of it, right? But okay, that's now let's look at so I have a method named display object, right? And this is how I implement display object. The display object actually use the geometric class, right? And it's pretty much just a parameters object. And it's going to call print, and they say object.get date and get color. Now, when I pass in the object, I pass in circle and I pass in rectangle. So I don't have to implement display object for circle type and rectangle type twice. Because if I do that twice, then like normally if you have to do this, you have to say circle instead, right? Are you with me so far? How many of you say I know I do not understand? Okay, like if I want in my main, if I create display object, okay, display geometric. How do I do that? I want to just print out two string again. And again, I'm going to have rectangle, right? Rectangle. And rectangle is going to extend what? Geometric, right? Now, in my main application, I have one method called display geometric that technically I wanted to print the two string of the object that I pass in. How do I do that? If the object is circle, you say, okay, then I have to say circle object. Is that right? That's the way you learn, right? That's right. Now, if I want to print rectangle, how do I do? I have to rewrite this guy again. Which, why don't I just do polymorphics? Since both of them are in the form of geometric, right? That makes sense? Since both of them in the form of geometrics. Geometrics. I should have created a package for them. Let me just move this guy out. We don't need this. Then this is called by, now I have to create geometric, right? Shape 1 equals to new rectangle, right? And then geometric shape 2 equals to new circle. See, then in this way, I could oh, this guy thought I want that circle. I mean, my one circle. I could just call display geometrics. Without, this is the benefit of polymorphism, right? This is called a polymorphic call. Then it's going to pick the right toString and display for you. See, this is a circle toString and that is the rectangle toString. So that's the benefit of using polymorphism. Instead of writing the code twice, right? Two methods with circle and with rectangle. Now you can make any shapes now. You don't have to worry about. Questions? So that's what it's trying to tell you here, polymorphism. So that's why we talk about dynamic binding. Like a method can be implemented in several classes along inheritance chain. And then JVM, Java Virtual Machine, is the one who decides which method it's going to invoke at runtime. Like for example, toString class method. The toString method is defined in object class. It's also defined in geometric class that we've seen. Now when we call object O, this is polymorphism, right? Equals to new geometric object. When we call O.toString, the question is which toString is going to call? Object toString or geometric toString? That's why we call dynamic binding here. So, answer to this question, we first introduce two terms, declared type and actual type. So a variable must be declared a type. The type that declares a variable is called the variable's declared type. O's declared type is object. Okay, so this is declared type. A variable of a reference type can hold a null value or a reference to an instance of the declared type. The instance may be created using the constructor of the declared type or its subtype. The actual type of the variable is the actual class for the object referenced by the variable. So O's actual type is geometric object because that's how we create it, right? Declared type is object, but actual type is geometric object. O references an object created using new geometric object. That's why the actual type is that. ToString method is invoked by O is determined by O's actual type. So this is known as dynamic binding. So object O is an instance of class C1, C2, and so on, where C1 is a subclass of C2, C2 is a subclass of C3, and so on. Is a subclass of Cn, right? That's the last one, right? That's a superclass. Cn is the most general class, and C1 is the most specific class. In Java, Cn is the object class. Like in this case, object is the most general class, right? JVM searches for the implementation of the method P in C1, C2 up to Cn in this order until it's found. Once an implementation is found, the search stops and the first found implement is invoked. So what's the answer to this one? Which ToString is going to invoke? Right, because it's going to go into the geometric first, right? This is called method chaining, right? The dynamic binding. If it's not finding inside, that's why it's going to call the ToString version. That's why when I show you when I comment the ToString out, it's called the object ToString instead. So since we know that, let's answer this example. So in my main, I have the method m, and the method m pretty much just defined inside my main to print the ToString. And this is exactly just like what I did, right? Like display, just like this guy, display geometric, right? Now, like for example, I can just change this to object. Because object is the parent of all the other classes. Correct? That's why the test is going to ask you like that. What should be the output? And the test doesn't have compiler with you. You cannot run the program, you just have the test and answer it. Then you have to understand. Yes. So you know this guy's going to invoke ToString. Watch which ToString is going to invoke. Remember, circle has ToString. Rectangle is not all. Doesn't have ToString. And we have this. Right? There is going to show the pretty much the same thing, right? So now let's look at the same question, pretty much similar, but it's just different question a little bit here on implementation. We have graduate student, student, person, and object. Now the question is, what should it print out? That's it. And it's going to give you, okay, graduate student extends student, student extends person, and person student override ToString and return the word student. And person extends object and override to string and returns the word person. All right, can you write out the output for me? Everyone has the answer? Need more time? Hmm? What's that? Ding, 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 ding. What's that sound? Mm-hmm. That make right. Ding, ding. All right, your time is up. You have to answer. And it's gonna be in your test. So what should the first one print? Student, because extends student, and it's fine student from student. That's right. The second one, student, because it's called student. How about person? Person, because it has two string. How about the last one? Object two string is what? The address, location that I show you like that, right? Because it's not implemented, right? So that's pretty much it. So that means you have a good understanding so far of dynamic chaining. So this is the part that you should go back, checkpoint, and review and prepare for the test. More exercises here. Even if you not really have the answer correct, then you should go to do that. Okay? Those are reviews. Now we know that we have many form of objects and we have object itself. So we have the technique we call casting objects. So what's casting? Like for example, if you look at where's the M new student, it's the same as I do like this. Object O equals to new student and M you pass O in, right? So this is called implicit casting. The instance of object O is known as implicit casting. It's legal because an instance of student is an instance of object. Because O is a student, O is also an object. So suppose you want to assign the object reference O to a variables of the student type using the following statement. Okay, can you do that? And O is an object, right? Can we say student B equals to O? Can we do that? Even O is student, O is object. Can you say student B equals to O? No, compile errors would occur. Why? The reason is that student object is always an instance of object. But an object, remember this is like O is an object. It is not necessarily an instance of student. It's just like the top, right, doesn't belong to the bottom, but the bottom belongs to the top, right? Not vice versa, right? The compiler is not clever enough to know it. So to tell the compiler that O is a student, you have to explicitly casting it to solve that issue. Like that's called casting technique, like change the type of O to a student object. Just like the way that you do casting with primitive data type, right? So it's always possible to cast an instance of a subclass to a variables of superclass known as upcasting, because an instance of a subclass is always an instance of its superclass. Just like this, right? Casting an instance of a superclass to a variable of its subclass known as downcasting. So explicit casting must be used to confirm your intention to the compiler with the subclass name. Actually, this is downcasting, right? Because O is object, right? Yeah, this is downcasting. So you must make sure that the object to be cast is an instance of the subclass. If the superclass object is not an instance of the subclass, a runtime class cast exception occurs. For example, if an object is not an instance of student, it cannot be cast, right? Like we know object is an instance of student, so that's why it can be cast. But if it's something else, then we cannot be casting. In this case, that's why before you do casting, we like to use the instance of operators to help to double check that. Otherwise, we could get a runtime exception, right? Class cast exception, and we don't want that to happen. So that's why before we do that, we just want to make sure we use if statement. Say my object instead of circle, then I can cast a circle. Make sense? So that's why instead of operators is being used. It's going to return either true or false. When false, then we never cast that. And then we never get into class cast exception errors. Any question on casting and instance of? Like this is not example. So I just have object and object instead in this case, right? And call display object. So you want to make sure you just use instance of to make sure it's object of circle before you print the area, and because we're going to have to cast that object back to circle as well as the rectangle. All right, so caution. You could do like this way, you see that? So object, right, you cast it to circle, and then you have to close parentheses. Now this becomes circle, right? Then you can do dot to have an access to the method of the circle. So the object member access operator dot precede the casting operator. So that's why I use parentheses to ensure that the casting is done before the operators. All right, so this pretty much is the review checkpoint. Now let's talk about equals. We already learned equals in toString. So it's going to return like Boolean, true or false. You pass in the object to compare, right? It just tests whether the two objects are equals. Now, how do we test that the two objects are equals? Right, each of its own data, right? Are equals, then they're equals. The default implementation of the equals is this equal object, right? They use the two equals operators. Check whether two references variables point to the same object. So if they point to the same object, then it's equals. So that's why you should override this method in your custom class to test whether two distinct objects have the same content, because otherwise rely on pointing to the same location. So it should rewrite at like this, like for the circle, you should just say first the O is instead of circle, and then check the both of the radius are equals, then they are actual equals. That's how you're rewriting it, right? For the equals method for the circle. So let's talk about array list. So array list, pretty much, why do we need an array? So if you use a variables, then it's only store only one value, right? But when you use an array, you can store a lot of values, right? That have the same type, right? So it's actually looking at it as the starting point of creating the memory. To store the values, right? The memory, right? Like the list of something, list of students, list of so if I want to create a list of students, I can just declare an array of students, right? Now, another way to store, we can use a class to store objects. Like you can declare an array of objects too, but we can alternately use array list to store student objects too. So what's the benefit of using this? So when you declare an array, you need to specify the size, right? Like you have to know the size in advance, how many students, then you create an array with its size. But for array list, you don't need to specify the size. The size will be increased dynamically at runtime. So that's one benefit of using array list. So using array list also, when you add, you just do call the method add and pass the element to add. You can add at a specified index in an array too, by specify the index and the element to add to that index. You can do clear, pretty much just remove the elements from the list. You can look at, hey, if the list contains some, just like normally we use an array, you just loop through it, but array list already implemented for you. You just pass an object, it's going to say true or false. You can get the elements at specified index out. You can get the index off by passing the elements. You can see if the list is empty. You can find the last index of the object, pretty much the last object in the list. You can remove the object from the array. You can get the size of how many elements are in the list. You can also remove according to the index instead of the object name. And you can also change the value of the index at that location by using set. Again, arraylist store an unlimited number of objects. So it makes dynamic like list as unlimited. That's a good thing. Second, it's also make it easier for you to use by just calling methods. instead of implementing your own. So how do we use Arraylist? So that's how you create an Arraylist. Use the angle brackets and provide a type. Since it's an array of objects, so it could be many types. So that's why we put a type in the angle brackets. Like you want to create city like string, array list of string, or array list of dates, right? Things like that. And that's how you start to use it. Just add cities, use the method say contains, return true or false, remove, right? So that's pretty much just showing you how to do it. Just call the method to use. So this is show the differences and similarities between array and array list. Like array, you have to specify the size like 10. Array list, you don't have to. You just say, hey, string type. This is you have to say string of an array. And when you get, you specify index. Array just provide a index. When you set right specify index and the values, this one just say a index equals to the values. And you say a dot length. So let's just say list dot size. Now to add elements, the array doesn't have that. Insert doesn't have that. Remove doesn't have that. Doesn't have remove all the elements. You pretty much just have to implement your own, right? But Arraylist is already implemented for you. Just call the method. Any question on Arraylist? This is just showing an application of using it. We can look at the application later. So Java provides the method for creating a list from an array. So if you have an array, you can just change it to the list. Like I have an array of red, green, blue. I could just create an array list from the array by just say arrays.addList and pass the array in. So this could create a list list.toArray, like let's test this again. So now let's see, we have these geometric shapes, right? So if I want to create an array list, let's create an array of the shapes. So I could, how do I create an array of the geometric shapes? So I could say geometric and then bracket, right? List equals to new geometric. This is an array. Let's say of size. Let's just do 2. Let's do 10. That's fine. So now I just create a list, and these are the geometrics. I could just say list 0 equal to shape 1, right? List 1 equals to shape 2. So now I have an array of geometrics. But we said we want to create array list from array. So we could just say array list, and this could be a type of geometric, and you have to import it from java.util. So now I got the geometric list equals to, we have to create an object of array list again, and again you could just type geometric between bracket, the angle brackets, or you can omitting it. Is the same thing because it's already defined once. Either way it's the same. Now but we want to create this from an existing array, so we have to use the keyword arrays.asList. So go to array class as list. So it's pretty much just going to turn to be a list. Return the list of the object list. Now I just make geometric list. So as an array, meaning that I have an access to all the method in array list now, because it's turned to be the array list object. So I could use the methods like contains. Let's see, we try to find, we want it contains shape 1. It should contains because we added in, right? If it does contain, it should returns true. There you go. So now if I want to test something that it may not contain, like let's say geometric shape 3 equals to new circle. So I may have a circle that with the constructors, let's say blue, date created, pretty much just new date for now, and let's say it's fielded, and the radius, let's say 9.5. So I just create a new one, and let's check I have an access to the array list to see if shape 3 is in the list. So in this case should return false, right? So that's pretty much has a method of array list to help. That is save time to implement your own loop, right? To loop and compare object and returns true or false. So that's one benefit of using array list too. So pretty much this is a list of things that you can use now. It's just like a small database now, correct? Like you can implement application and you want to store something, you can just use array list to store information, like account of the user, student object, user object, right? When you write an application. So we were looking at changing the arrays to array list. That's how we do it. Using this. Now this is array to array list. And we can do the other way around. We can make array list to an array. So this is how you make array list to an array. To array and store that into the array.
So suppose we use int instead of integer, will it still work? Integer square bracket array. If we change the integer to just int, will it still work? It's on the array list.
Yeah. This is just a wrapper class. You can still. Oh, but this one. No, you have to have the object type. You cannot do int here. Has to be object type. So this is just showing you, like, if I have to implement how to sort, it's going to take a while. You can just use this is just show you how to sort. So we have arrayed and sorted, and then we can just make it to Arraylist. Now we can just make the method of the collection.sort to sort the list, and then the list will be sorted. Collection is pretty much just an interface. We can talk about interface. Collection.sort. Yeah, it's just like a framework that provides and store and manipulate a group of objects. Like when you have an array list like that, you pretty much want to store and search if it contains the object. You can sort the objects. You can insert, you can delete or remove objects from the list. So it's a framework, provide interfaces like set list. This is pretty much the things that you need to know in 202. It's pretty much just when we talk about the list, we can have many type of lists now. Like very simple, like when you go to check out at the grocery store, you have to do the queue, right? Like when you talk about just a shopping list, it's just a list, or the roster list of students, just use list. And then, yeah, these are just different type, like vector, pretty much just like another way to collect the data. Right, we can collect into the tree structure, we can collect into the linked structure, which you learn more into it too. And we can set the priority, like doesn't mean have the first one in the queue has to be the first person. We can make like set on the priority, like if it's emergency, you can go first. So we call priority queue. And we have hash that just like when you look up the list from the dictionary, you can look at a keyword. Like hash is a key, like the word itself and the definition of the word will return. So that's the collection. But let's see the collection itself, the class collections, right? They have the method that we see. They set a list of all the method summary. You can find max, min. So that's why this one use one other method to say sort. You pass the list in, it will sort the list for you and print out. And they have the method to do max and min. You return max and min value of the list. It's pretty much just a. Remember we look at inheritance, right? So if you look at collections and you look at Arraylist, so when you read the Java doc, these are inheritance. right? Arraylist, abstract collection, implement, collection. So we just talked about inheritance, right? Collection itself extends from object. So now when we come back to this one, we could access to the method of collections again to shuffle the list. Now this is just at the end, it's just a checkpoint. So now let's look at the custom stack. So let's look at, now we understand how to use Arraylist, right? It's just the basic starting point of create the memories to store information. But in terms of data structure, after you store the data, you have to think about, now we know how to store, we can store into Arraylist because it's very easy to manipulate it, right? We show you can get max, min, sort, shuffle, and so on, right? Can search. Then you don't want to spend time to write that on your own anymore, right? In using array, right? But after we store the data, we want to use that in the application now. When we create an application, we're looking at which type of data structure we choose use to store the data. For example, if I want to write an application for Word documents, I want to make an option for recently open, recent, like that. So what should be this list? This can be an object, right? Object of Word document file, right? We can make a file as an object, right? So what should we do? How are we going to implement this feature? That's it. That's a simple question. I want to make the application to keep tracking on the history. So that means you need a memory. And we say, okay, we can use Arraylist, right? Now we keep storing the list into the Arraylist by adding the object every time. Now, how I get to the last object that I just add? This is the last object. You technically just go to the last index of the Arraylist, and then you just make the order this way, right? This is going to be your last index. This is your first index, right? And this type of data structure is called stack. Why stack? You keep pushing in the stack the last to the top. The top one is the last one that you use, right? So this is a stack. That's just called stack data type, like data structure stack. That makes sense? And then how you going to implement stack? That's another question. The list itself only the place to store the data. But to implement stack, you have to put a logic that I just told you, right? Go to the last index, that is the top of the list. So that's why stack is another class that uses Arraylist to store the elements. But stack itself has an operation we call push. Push just like every time I open a new document, I keep pushing in the stack, right? And then I have another operation we call get size. You can see how many size in my history already, right? Or in the list. I have another option called is empty. That means nothing. First time I never open anything, right? Stack is empty. I have another operation called peek. Peek pretty much just look at what is at the top. At the top in this case is CST 201. Just look at, hey, what's the last document? Alright, those are the common operations for stack. Pop, that means I start to remove the top of the stack one by one. Okay, so now we understand the operation of stack, right? Any questions? And this is application of Arraylist now. We can store the data and we can use this in stack. Like I said, is it empty? Very simple, because Arraylist already have the method is empty. Easy to implement. Get the size, just list the size. Peek pretty much just get the last index -1 and get that, right? Get the size pretty much, because size is going to be greater than 1, right? Because index start from 0, that's why it's -1. Pop is you try to remove, so that's why you have to do list.remove at the last index. But you want to store that to get it first and return the object. That's how you implement the pop, right? And push pretty much just add to the list. And then we have toString version, pretty much just return everything in the stack. By calling list.toString, it's going to add thread to it, because Arraylist already have that implemented. So make it very simple to make a stack. Any question on stack? All right, so now let's talk about protected data. So you guys need a break and come back, or no? Or you want to leave early? Okay, I think we're almost done. It's actually the last one, and then done. You can leave early, right? All right, so protected data and methods. So a protected member of a class can be accessed from a subclass. So that's true. Let's talk about modifiers, right? So these are the modifiers. Let's go back to geometric. Private. Only have access inside, right? Circle, radius is private. Now, if I make protected, let's say name, so the question is, remember, the good question should be this first. Can circle have an access to color of geometric? How? When you say yes, if it's yes means, if you look at geometric, it's private. How could I have access to private? Yeah, you can get it from that, but you cannot access to the color, right? Because private, right? Now we use protected. Can circle. Now when I say that, meaning like for example, I want to access to geometrics color inside. So that means I could call super, right? To refer to parent, correct? Dot. See that the only data field that I can access to is the name because protected. Then I could just say give the name to the geometrics. That way, right? Because it's protected. With private, I cannot have access. I cannot say the color like that. I have to involve through the method instead, right? So that's why I said protected member of a class can be accessed from a subclass. That's what it means. I just show you, right? So you have learned private and public, right? So to specify whether the data fields and method can be accessed from outside of the class. And private members can be accessed only from inside of the class. And public members can be accessed from any other classes. So often it's desirable to allow subclasses to access data fields or methods defined in the superclass, but not to allow non-subclasses to access these data fields and methods. Okay, so meaning, let's go back. All right, so my question is rectangle. Rectangle is a subclass of geometric, right? Then rectangle should also be access to name, correct? So we can see if I call super dot, let's call this guy first, super dot name. Then we can give the name. Now, how about my main? Can main access to that name? Like I have the geometric, right? Like, can I say shape1 dot name? But main is not a subclass of geometric. Now let's do a little bit different. I'm going to create new package. Let's put package for the main then. Let's put package for package, just a folder that organizes your classes, right? Shapes. Let's move this guy into that shapes. Okay. Now, then I want to do that because I want to make a package then you import when you use. See that? That's why I want to make that. All right, so let's fix the problem a little bit. It looks like it's just keep importing this for me. So I need to import shapes, right? Another word, you can just use asterisk, but it's better to define whatever object you are importing than use the asterisk. Asterisk is all the classes here. So what happened to rectangle? I don't need this. It's just defined at AWT package. Oops, I cannot have an access to the protected anymore. So meaning that the protected data fields can have an access through the subclasses and any other classes that resides in the same package. Before it works because it was in the same package, same location. But protected will not allow any other classes that reside in different packages. Make sense? So that's the key. So that's pretty much it. That is protected modifier. Subclass, yes. Same package, yes. Make sense? So that's why we have this table. Public to the world, right? Protected, same class, yes. Just like private, right? Same package, yes. We just seen it. Subclass, yes. Private, only in same class. Now lastly is what default. Default is just like you declare without modifier. So in that case, it's allowed in the same class and the same package to access. Okay, for default, but not subclass, right? Is that easy to understand? Yeah? Questions? Because if you read this, it may take you a little while to understand. Okay, but I just show you that. That should make it easy for you, simplify. And that's pretty much it for that section that they want to talk about. This is pretty much, you want to go back and I can review one more time. Let's test. So class C1, we have the package P1, right? And this package P2, right? Class C1 has public X, protected Y, default Z, private U. This is pretty much going to be on your test, okay? Just like that. And class C2 has default. Now, we said this is define O, right, from C1, an object of C1. Can it do O.X? Yes, because it's public, right? O.Y? Yes, because it's the same package. Even it's not inheritance. O.Z? Yes, default will be valid in the same package. O.You because it's private, right? And M is protected. Yes, it can work because in the same package. Now C3 extends C1. Access X, of course, yes, public. Y, yes, because subclass. Z, yes, because same package. U, no, because private. M, yes, because subclass. Now different package, C4 extends C1. Access X, yes, public. Access Y, yes, because subclass. Even different package because subclass. Access Z, no, because default only valid in the same package since this is different package. Access U, no, because private. Can invoke M, yes, because subclass. Even it's different package. How about C5? C5 not extend anything. Can invoke X, yes, public. Y, no, because not subclass and different package. Z, no, different package. U, no, private. Invoke cannot invoke M because not subclass and different package. That makes sense? So you guys see something like that in the test, you should know. So that's pretty much the modifiers. And these are a checkpoint that you can practice for the test. It's going to help to practice those at the end. Like you just keep asking where you can read and practice. These are the places you want to practice. Practice question for the test at checkpoints for each section of the chapter. Now, lastly, how would you prevent extending and overriding? We know that whenever we create a class, another class can keep extends from it, right? And then override the method. What you can do is just put final in front. So if a class is final, neither a final class nor a final method can be extended. Final pretty much a constant, right, that we normally use. We can just use it. Like the math class is also a final class, like in the Java library. This is public class collections. So let's look at math Java doc. Final, see that? My class is final class, so no more extended from that, right? String builder, string buffer classes are also final classes. We never noticed that, right? So we use string all the time. Also final. Okay. So that's pretty much the same with the methods. If you don't want override, just the final, then cannot be override. Let's say, for example, we try to override to string. Let me try final. There you go. You cannot override anymore because method is final, right? ToString cannot override in shape.geometric. Operated method is final. So if I make a class as final, now circle and main has errors now. Circle. You cannot inherit from final geometric. So it's going to compile it, just check and tell you. And that's pretty much the end of chapter 11. So you technically can do assignment for that too. Okay. So I think we should start talking about your final project too, since you have more time. Now you want to review for your test and also think about final project. And your final project pretty much an extra credit. Do we have that as part of the syllabus? Let's check. Not sure. I thought I may put it. Nope. So you have assignment 500, midterm 200, and final exam 300. And then you can have another 10% for final project. It's just on the top. If you feel like your midterm final is not good, you can use that to help. Okay? So since you have a lot of like, if you keep tracking on finish assignment early, then you have more time to start working on your final project. Okay, you have about, it's gonna be due by the end of the class, second week of December. So this is a good time to start, about 2 months, right? Right. Then you have time a little bit by bit, about 8 weeks. Questions?
Yeah, what is the midterm?
Oh, it's next class, midterm.
It says 27th on the syllabus.
Yeah, that's for we separate into 4 units. Unit 1 and 2 next class, and 3 and 4 on that 27.
Oh, really?
Yeah, because if you do everything in one at once, it may be a lot of time and also hard for you. So we separate into 2 sections, okay?
Okay.
Because remember, unit 1 and 2, you have probably almost 10 chapters already. 1 to what?
Either 1 and 2 is chapter 1 to
Yeah, 8 chapters already, right? About 7 chapter because excluding 4.
Yeah, okay.
Then if you get everything at once, it's gonna be hard on you. So I actually try to make it into sections, it's better, right? Then you can review that section and come for the rest. Any other questions? All right, so